Hey everyone, Kevin here with some Exam 1 sample questions. Here are the sample questions I will go through in this video. If you want to stop it here and work on these yourselves, please do so, and then I will solve them for you. Okay, here we go. Spoiler alert, solutions are coming. First question. These first three actually are examples of the type of multiple choice questions that will be on the exam. So let's solve the first one. It's 1250 millimeters, and we need to convert that to centimeters. So our conversion factor is 1 centimeter for every 10 millimeters. If I cancel units, I cross out millimeters here and here, and my answer is 125 centimeters. I have to report that with the correct number of significant figures, and here there are 3 significant figures in 125. So let's look at the potential answers. First answer, that's just wrong. D, that's wrong. So what about what about B and C? Well, they both appear to be 125 centimeters. Which one has the appropriate number of significant figures? Well, B is 3 significant figures because when you have scientific notation, the coefficient, which is 1.25 in this case, that is all the figures in the coefficient are significant. So we have 3 significant figures. In C, we actually have 4 significant figures because of that decimal point. That makes the 0 after the decimal point significant. So we started with 3 significant figures, and we want to report 3 significant figures. So number C is not the right answer, and we're left with B. Question number 2. Classify the following. A piece of gold in dirt. That is a heterogeneous mixture. Gold is not going to dissolve in dirt. It's going to sit there. And so we're going to clearly have a mixture of different things, gold and dirt. In contrast, say if we were dissolving salt in water, then you have a homogeneous mixture because the salt is evenly dissolved throughout the water. You can't distinguish the salt from the water. All right, but in this case, we've got a piece of gold in dirt. It's not simply a compound because there are lots of different molecules in there. It's not an element because we've got gold, which would be a pure element, but the dirt contains all kinds of other things, so it's not just an element. It's a mixture, and it's a heterogeneous mixture. Third question, which element is described by the chemical symbol Fe? Well, there are only 2 on this list that you are required to memorize, fluorine and iron. But in spite of that, you should know, if you know the chemical symbol for iron is Fe, you know then this is the answer. And you can eliminate all the other ones, even the ones that you haven't memorized. All right, let's go on to the short answers, starting with number 4. Here, we start with 20 mils of pure acetic acid. So we start with mils. Those are our starting units. And we want to get to grams. So grams are the ending unit. So we need a conversion factor that converts milliliters to grams. And what is that? Well, we're converting a volume, milliliters, to a mass, grams, and what does that? Density does that. And we're given the density in the upper right here in this box. So we can set up this problem by just saying 20 mils times 1.05 grams per mil, and we do the math and we get 21 grams. Let's check. We can cancel units. Milliliters here and here cancel, and we're left with units of grams, and so that's what ends up in our answer. Does the answer look reasonable? Well, 1.05 grams per mil. That means there's more grams than mils. So our answer should be higher than 20, and it's 21. So that passes the big picture, do it in my head math test, and it looks like we're good. So 21 grams would be what I would answer here. How about the next one? How many moles are in 21 grams of acetic acid? All right, so here we're starting with grams as our starting units. Our ending units, we want moles. All right, so we need a conversion factor that relates grams to moles. All right, well, what do we know about grams and moles? We do know that 1 mole of something, either an atom or a compound, is equal to the formula weight in grams. And if you haven't seen my supplemental video on moles, just check that out. So let's go over here on the right and let's do the formula weight, formula mass of CH3CH2 or CH3COOH. So there's 2 carbons in there, right? So that's 24 atomic mass units. There are 4 hydrogens, so that equals 4 atomic mass units. And there are 2 oxygens, and that equals 16 atomic mass units. Oh, I'm sorry. Check that. 32. 2 times 16. All right. So we've got 24, 28, 58, 60 as our formula weight or formula mass. All right. So we know then that 1 mole of acetic acid is 60 grams, right? A mole of something expressed in grams is the formula weight in grams. All right, so we just set this up saying 21 grams is what we have. Our conversion factor is 1 mole for every 60 grams. And we do the math and we come out with 0.35 moles. And let's do our usual double checks. The first check is to cancel units. So remember, 21 grams can always be written as 21 over 1. That's the same thing. And that makes it clear that grams here is in the numerator, and that cancels against grams in the denominator. Moles, that's the unit we're left with, and so that ends up in our answer. So units look good. We canceled them correctly. What about our second test would be kind of do a big picture, do it in my head math test. Well, 20 divided by 60, that's about 1/3. And we come out with 0.35, that's about 1/3. We're going to have, the other way to do it would be to think about the fact that we've got a fraction here that's less than 1. 21 in the numerator, 60 in the denominator. So we need a number less than 1, and our answer is less than 1. So it looks good, and this is what I would report for this question, 0.35 moles. All right, let's do number 6. How many molecules of acetic acid are in 0.35 moles of acetic acid? And note that I added here, report the appropriate number of significant figures. All right, we start with moles. All right, so our starting units are moles. Our ending units are going to be molecules. We want the number of molecules. All right, what conversion factor relates moles to molecules? Well, we know that 1 mole equals 6.02 times 10 to the 23rd molecules. right? 6.02 times 10 to the 23rd particles. In this case, it's molecules because we're dealing with a mole of the molecule acetic acid. So we can set this up by saying we start with 0.35 moles. We multiply that by our conversion factor, which is going to be 6.02 times 10 to the 23rd molecules per mole. And we do the math and we get 2.107 times 10 to the 23rd molecules. All right, let's do our double checks. First, let's cancel units. So moles here in the first term cancel with moles in the denominator of the second term. We're left with molecules as our ending unit, and that's what ends up in our answer. So we're good there. What about doing the math in our head just as a quick double check? Well, we would multiply 0.35 times 6.02. That yields 2.107. Does that look right? Well, 0.35 is about a third. A third of 6 is 2, so that looks right. We also know that we are looking at a fraction here of 1, so we know the number 6.02 has to go down, which it does, to 2. So I think we're pretty good. Now all we have to do is think about significant figures. Well, up here where we started, we had 2 significant figures in moles, right? The leading 0 here is not significant. In the coefficient of scientific notation, we had 3 significant figures. So our minimum is 2. In multiplication, we're going to use the lowest significant figures of the things we're multiplying. So we would report this as 2 significant figures. So we would go with 2.1 times 10 to the 23rd molecules. All right, 2.1 is 2 significant figures, and that's what we want to report. And that's how I would report this answer. Thanks everybody for watching. Let me know if you have questions. Just shoot me an email. Good luck on the exam.